So for this bell work, they've given us a slope because this is already in slope-intercept form. And we know that the slope is the coefficient of x. It did give us the y-intercept here, but it's not asking for us to use or to find any y-intercept. So we don't really care about that, but we do care about the slope. So parallel slope is going to be the same slope. So where this one is showing right now at negative 4/3, the parallel slope would be exactly the same at negative 4/3. Perpendicular slope, on the other hand, is a little different, just a little different, where we're going to have to take that slope and find its opposite reciprocal. So right now the slope is showing as negative 4/3. It's negative, which means its opposite will be positive. So I'm going to show that positive sign there, even though you wouldn't show that usually, but you're welcome to if you'd like. And then just flip the fraction. That's the reciprocal, which now makes it 3/4, positive 3/4. So we have the two slopes. The parallel one, which is negative 4/3, is the same. And if you were to graph that, that'd be down 4 to the right 3. And then the perpendicular slope, which is 3/4. That'd be up 3 to the right 4. There's our two objectives for the day. I can write equations from word problems, and also I can interpret x and y values in slope and y-intercept from word problems. So take 30 seconds, copy this down, please. So when it talks about writing these in these equations, we know we're going to be using slope-intercept form. So it's going to take this form y equals mx plus b. And we know in this format, y equals mx plus b, m is the slope, that's the coefficient of x. And the y-intercept is just whatever's being added or subtracted there. But now it's in word problems, so they may not be using y values or x values on this one. So we have to keep that in mind. They may actually force us to use different letters, and that's okay. We'll look at that, and if we can remember a little bit about 8th grade and some science classes we've taken, then we know that the x is what we call the independent variable, and y is the dependent variable. So if we can just determine which of the two values depends on the other, then we know we're looking for the y value. In some situations, they won't be necessarily independent and dependent, which sometimes makes writing those equations easier, but we'll see. So the two things you need to write, the equation of a line, just like we saw, is the slope and the y-intercept. Okay, so usually the m there is usually some kind of blank that you got to fill in, and same with the b value right there, the y-intercept. It's just now they're going to be written in word format. So in these words, in these word problems, you're going to have to read and reread these several times until you get used to them. So once you get some experience, you may not have to read them as many times, but until then, expect to read the problems at least 3 or 4 times, okay? Going back through the problem, making sure that you're using the correct values in the equation. Now, they're not going to say, here's the slope like they have in the past, unless they give us slope-intercept form, which would be convenient. But in the problems, the slope you're going to see is some kind of rate. In the past, you've seen this as a rate of change. In fact, something else, this kind of goes back to 7th grade, a little bit of 8th grade. But you're also going to see some kind of unit rate. That's, from what I've seen, that's what they're usually going to show you, okay? Some kind of unit rate, well, what's the difference? Well, unit rate is where one of the values is 1. So in a unit rate, they may say something like, you got something per something else. Again, it's not exact wording here, but something close. Or they may say something like, you got something for each of something else. Okay? And today we shouldn't need the slope formula there, so don't worry about that. But again, you're looking for kind of this wording here, per or for each. Really, you're just looking for a comparison of two values. That's what a rate is. Whether you remember that or not, hopefully you do now. And then the y-intercept is some kind of starting value. And no surprise here, but some of these problems were written by math nerds. So sometimes what you'll see is they'll say initial value. So now you know if you want to be a math nerd, you'll say initial value, not starting value. But it means exactly the same thing, okay? And that is your y-intercept. So if they say you start at 500, okay, then you know that's your y-intercept. And if they say you're doing 2 cups per batch, okay, that would be a slope for you. And then you can insert that again into your slope-intercept form. All this is stuff we've seen. Again, we're still applying this into slope-intercept form for the most part. But we've seen that before, so hopefully, again, it's more review than anything. So on the assignment as well, they're going to have these tables for you to fill out. And again, you may have to read and reread these to really figure out what is going on so that you're using the correct numbers. If you don't, then you may make some mistakes along the way, and that's okay too. We can learn from those. Let's read this so we know what we got going on here. So you are going to drive from your house to city A without stopping. You plan to drive at a speed of 50 miles per hour, and your house is 200 miles from city A. Make a table of values and then write an equation for D in terms of T, representing your distance from city A, T hours after leaving your house. So a couple things on this one. It says D in terms of T. Whenever you see in terms of, it's always in terms of X. So just in case you didn't know, now you know, because you're going to see this stuff on the side, okay? So D, it would be the Y value there. Or in other words, again, if you think about what you've learned already about independent and dependent variables, D here, the distance you're driving or the distance you are from city A will depend, which makes it the Y value, it will depend on how many hours you've been driving. So let's go back to the words here. And I see that it said you were driving at a speed of 50 miles per hour. It's saying that it's in miles per hour, right? So we know that that's a rate. But not just any rate, it's per, you could even put a phantom 1 there. So we know it's a unit rate. Since we know that it is a unit rate, we know that it is the slope. Now that helps us when we get to the equation, which we will. I'm going to fill out the table first. But in addition to that, they also said your house is 200 miles from city A. Now that right there should be where we start. Start from your house. So we know that it should be our y-intercept, okay, for the equation. So right now we could actually write the equation, but before we do that, let's fill out this table, because on the assignment you're going to have to fill out the table and then you can write in the equation. But the two values it gives us, number of hours driving and distance remaining to city A, just so we understand from these tables, it's always the X value on the left and Y values on the right. And that is because these are all going to be their own ordered pairs. So if you wanted to graph them, you could. I don't suppose you would though, unless they made you, but here we are. So right here, number of hours driving, you haven't driven at all if you've been driving for 0 hours. So how far away are you from city A? What distance do you have remaining? Well, that means you'd be at your house. That's 200 miles away. And then we can see as well that this ordered pair has an X value that's 0, which tells us, again, in another way, that we have in fact found the y-intercept. Now from here, we got to use the driving speed. Somehow this person's going constantly 50 miles per hour every time. But if they drive 50 miles every hour, then in 1 hour, here, put this in. So if you drive for 1 hour, you're going to go 50 miles. Now, from that 200, you're going to subtract the 50 because you're getting closer to city A, right? You're driving to city A. So 200 minus 50, which I would recommend just putting into the calculator, means that after that 1 hour, you'd be 150 miles away from city A. Okay, well, let's say you drove another hour, which is shown in the table here. Then you'd take off another 50 miles. Now, you can show the work like this. In the past, in 7th and 8th grade, when they were doing this kind of stuff, they probably showed it like this. So that's what I'm going to stick with here. 150 miles minus that 50 miles that you've just driven means that you are now 100 miles away from city A. But then it says you're going to drive another hour. So that's another hour. Okay, fair enough. Let's take away another 50 miles because we're getting closer. And the negative is what means that we're getting closer there. So 100 minus 50, boom, 50 miles. So from this table, of course, it wouldn't be that hard to say, well, how many hours you have to drive in order to get to city A? Well, I would just add on another hour to this table. And then we would see, you take off another 50 miles there, and you'd end up with 0 miles. You'd be at city A, okay? So interpreting some of this information, just a little bit of it, if you haven't driven at all, then you'd be at home. Okay, so that's something that you'll want to keep in mind when interpreting some of this stuff. But if your distance remaining to city A is 0, that means your distance from city A is 0, you're at city A. Okay, but again, this ordered pair would tell us it took 4 hours to get to city A. They didn't ask us about that, but they may on the assignment, so just be aware. Now, the last thing here is we want the equation. So I'm going to start this in slope-intercept form, okay? Just standard slope-intercept form. We had the speed of 50 miles per hour right there, right? But as we can see, we were taking it away when we did the calculations in the table. So that's because we were getting closer. So we need to make that 50 a negative because we're getting closer to city A. And then we know the y-intercept. Well, you were 200 miles away from city A to start with. Now that's pretty, but it's not the equation they want because I'm using y's and x's, which is what we're familiar with. But we remember from the words that it wants d in terms of t. So instead of a y, you'll want to use a d for distance, and then the x is number of hours that you've been driving. Now, with the table, just in case you forget, you can remember that d is distance, because it said it was distance here, and the y value is always on the right in the table. Or you can tell that the x is the number of hours, which they're saying is t, which again, that's just to clarify where these letters are. So then we just plug in the two values. We had a negative 50 slope or rate, unit rate there, and then a 200 miles away from city A. Now some students, even at this point, they prefer to say, look, I'd really like to just start at 200 miles and then take 50 miles away every hour. Both of these are good. So on the assignment, whether you put this one in or this one, you're good. It'll give you full credit. So another table one, when you left your house this morning, your cell phone was 50% charged, and then it started to lose 5% charge for each hour thereafter. Write an equation for B in terms of T. So just so we remember, that's Y in terms of X for us. When we write the equation, representing the charge remaining in your battery as a percentage T hours after you left your house. Now in the table, we got number of hours since Justin, or you, I guess, left your house. Percentage charge remaining on the phone or battery, which is, again, that tells us immediately what the X and Y values are for the table. But the other thing is some students get mixed up because this is a percentage right here. So we don't need to actually change these percentages into decimals. They want the actual full percentages on this. Now that means also, since it's labeled for us in the title for the Y values, that we don't have to worry about labeling these as percents. So it says number of hours since Justin, or you, I guess, left your house. Right there is 0. So that means that you wouldn't have left your house. Then we know that you were at a 50% charge. Okay, that's what it was when you left your house. So in here, the percentage charge remaining on the phone or battery, 50%. But again, this tells us right here that we have the y-intercept because the x value is 0. Then after that, it says it will lose 5% charge every hour. But again, this is telling us we have just found a unit rate. And we know the unit rate is also the slope. So right here, after 1 hour, you would have lost, so we're going to subtract 5%. 50 minus 5, 45%. So after an hour, you got 45%. If we take on another hour, then you will lose another 5%, which would put you at 40%. 45 minus 5 is 40. And then another hour there would mean losing another 5%. So that would be 35%. Now from here, of course, you can see you're losing 5% every hour. Again, you may ask, well, how long would it take to drain the battery completely if you don't charge it between now and then? But I'll leave that one up to you, okay? But that's the table. On the assignment, after you finish the table, you'll have to click on finish with the table or something like that, and then it will pull up a box for the equation. So our equation, slope-intercept form, y equals mx plus b, but we did find the unit rate, right? That's the 5% charge each hour. Now again, you don't need to change that into a decimal value. But in addition to that, again, don't forget that you're losing that 5%, which is going to make that 5 a negative. Okay, well, what did you start at? Well, up here, it said you started at 50%. Okay, so I know that I have a positive 50 right there. And yes, we did find that in the table. Again, I'm just showing you that different ways that you can tell that you have found your y-intercept. But again, this one does not want this in terms of y and x. It wants b in terms of t. So instead of the y, I'm going to use a b. And instead of an x, I'm going to use a t. So b, looks like that's the battery left, would be negative 5% times the number of hours plus the 50% that you started with. But again, the order can be different if you prefer it to be. You can say that you're going to start at 50% and then take away 5% every hour. There we go. Now in the past, it's possible you've seen tables like this and then you know how to find the slope this way. Again, slope is the change in these y values compared to your change in the x values, because we know slope is a ratio of change in y over change in x. You are in the business of manufacturing phones. You must pay a daily fixed cost to rent the building and equipment, and also pay a cost per phone produced for materials and labor. The labor and materials cost $100 for each phone manufactured, and the total cost of producing 9 phones in a day would be $1,400. Write an equation for C in terms of P, representing the total cost in dollars of producing P phones in a given day. Nice. Well, for this one, again, it's C in terms of P, and it's always Y in terms of X. So that tells us what the Y and the X are. So when we set up our equation, Y equals mx plus b, you could kind of simultaneously set up as C equals mt plus b. But what values did they give us here? Well, it says, the labor and material cost is $100 for each phone. So for each phone, well, I put T, didn't I? But it should be a P. C in terms of P. There we go. P is phones. Okay, well, $100 for each phone. That, again, shows us a unit rate. And while you don't see the one, it's there. It's just a phantom one for each one phone. So that would be our slope right there. Okay, so $100 for each phone. So you could put that as 100x or 100p. But again, this isn't showing the y-intercept, but we just got to fill in this blank is all we got to do. But then it says the total cost of producing 9 phones a day would be $1,400. This right here is an ordered pair. So we know X and Y would be our ordered pair, but this one is showing X is P and then the Y is C. And again, how do we know that? Because it told us it's C in terms of P, right? So the cost for those 9 phones would have been $1,400, so that's my C value there, $1,400, and that was for 9 phones. Okay, so what we have here is an ordered pair. They did not give us the y-intercept, which is the cost to rent the building and equipment, right? So we're gonna have to use our Y-intercept formula. So we take the B equals Y minus the slope, M, times the X. Well, we already have the slope. We know it's $100 every phone. And then the X value comes from that ordered pair. That's P, the number of phones, was 9. And then the Y, that's the cost for producing those 9 phones, was $1,400. So this is something that I just put in the calculator, and it would tell me that B, the Y-intercept, would be $500. Okay, now again, this is an interpretation. B should be the fixed cost to rent the building and equipment, which they did not tell us what it was. We had to find that on our own. So that's going to be $500 just to rent the building and equipment. Now, of course, in the Y equals mx plus b, that's plus 500. But we've changed the variables because they told us to. C equals 100p plus 500. Now, the last 2 examples we did, the slope was negative here. That's because you were getting closer to city A or you were losing battery percentage. This one, though, all of this is cost. The $500 is a cost to rent the building and equipment. And then it costs, again, more money to produce each phone. So this is the one that we want. Again, you could rewrite it because some students prefer it that way. They say, well, it's going to be that $500. And then in addition to that, you're going to add $100 every phone. But again, it doesn't matter which one you choose to use. I like this one just because we're still trying to get used to slope-intercept form. There it is. You're going to use a computer at an internet cafe. The cafe has an initial charge of $10 to use a computer and an additional charge of 80 cents for every minute of use. Okay, write an equation for C in terms of T, and again, that's Y in terms of X. So we know that the C is the Y and the X is now T. So when we write the equation, Y equals mx plus b, just filling in the blanks, I now know what Y and X represent. Y is C, the cost, the total cost of using a computer for T minutes at the internet cafe. Told us right there in the problem. All I need then is to fill in my slopes here and then the Y-intercepts, but they're going to match. Again, I'm just showing that the format is now changing the letters. So what do they tell us in this problem? Well, they said that there's some kind of initial charge. And again, there's that word initial. That means that it's some kind of starting value. So they're going to start by charging you that $10 right there. And since this is all cost, we're going to add that $10 in. And then they say, look, they're going to charge you 80 cents for every minute. And again, that's a unit rate for every 1 minute. So since we know we have found a unit rate, we have also found the slope, which is 80 cents, which we're going to keep as 0.80 for both equations, okay? So this one, again, just to save time here, I'm not going to rewrite this one, but again, you could rewrite it as 10 plus 0.80 t if you'd like. This one or the other one is the one they want, okay? So this one was nice because they gave us the slope and the Y-intercept directly in the problem, so we just had to fill it in. And if we can get used to that, then we can do well not only on the assignment, but on the test. You're driving on a long road trip. You currently have 11 gallons of gas in your car. Each hour that you drive your car uses up 1.75 gallons of gas. How much gas would be in the tank after driving for 4 hours? And also how much gas would be left after T hours? So a couple ways you can do this. You can do it the old-fashioned way. Right here they say you currently have 11 gallons of gas in your car. Now again, that's a starting value, which we'll get to. Then it says you're going to use up, your car uses up 1.75 gallons of gas. And while this does not look like a unit rate, it does say it's for each hour up here. So that does tell us that it is the unit rate. Okay, so to figure out how much gas you're going to use after 4 hours, we'll take the starting gas value, 11 gallons, and you can just subtract 1.75 from that. Okay, now again, this is only for 1 hour. but you'd have, looks like 9.25. Guess I should use a calculator, shouldn't I? 11 minus 1.75, enter. Boom, 9.25 gallons. But again, that's after 1 hour. But I have to do this for 4 hours, right? So I got to take away another hour. So that would be another 1.75 gallons, 1.75 gallons of gas for another hour. So 9.25 minus 1.75. Again, just use a calculator for that, but 7.5 gallons after 2 hours. But then we need another hour, right? We're trying to get to 4 hours, so we're going to take away another 1.75 gallons, which would show me how much gas would be left after 3 hours. So minus 1.75 from 7.5 tells me you got 5.75 gallons left after 3 hours. One more. I've got to take away another 1.75 here so that we can see how many gallons are left after 4 hours. But this would result in 4 gallons even. Okay, so how much gas would be in the tank after driving for 4 hours? What we just found there would be 4 gallons. So how much gas would be left after T hours? Okay, so this wants gas in terms of T. So again, that's Y in terms of X right here. So when we set up slope-intercept form, Y equals mx plus b, it's gallons in relationship to number of hours driven. And again, just in case you didn't realize that from this wording, the number of gallons will depend on how many hours that you've driven. So gallons is Y, and then T is the X. So they did tell us as well that you're going to use up 1.75 gallons every hour, but you're using it up, which makes that a negative 1.75 slope. And then again, they gave us a starting value of 11 gallons there, so plus 11. So again, we're just filling in the same values here for the formal equation. And again, if you wrote that as 11 minus 1.75 T, you'd still get full credit. Now, having found that equation right there, what you could have done to solve this one is you could get the equation first, and then since we want to know how much gas would be in the tank after 4 hours, you could replace that T with 4 and then solve it, but again, you'd still get the 4 gallons of gas for 4 hours, and that would produce a new ordered pair. I guess it'd be 4, but if you need ordered pairs, that's what all this information is providing as well. Like this would be 1, 9.25, 2, 7.5, and then 3, 5.75, or 4, 4. This is the one that's a little different, so you have to be aware of that on the assignment. They will give you a couple that may be a little different, like this one. You find some dimes and quarters under the couch cushions. How many coins do you have if you have 9 dimes and 11 quarters? This one, some students have been making this a little bit more complicated than it is. How many coins do you have, right? Coins. Well, the coins are actually dimes and quarters. Okay, so all we're doing here is taking the dimes and adding the number of quarters. And here they said, well, you got 9 dimes right there. So 9 dimes and 11 quarters. So all we're going to do to figure out how many coins we have is just 9 plus 11, which would be 20 coins. So that answers the first question there. But then it says, how many coins do you have if you have D dimes and Q quarters? I'm going to keep it in this format. And that's what's different now. It's not telling us specifically what a slope is or a y-intercept. And I don't think that dimes or quarters really depend on each other. And so this setup right here is good. They say that instead of dimes, they want D. Instead of quarters, they want Q. So those are 2 variables I'm going to use. That would be the number of coins that you have. On the assignment, this is the only part that you got to fill in, this expression. But again, that would be an equation for a number of coins as well. So again, this one, just don't overcomplicate it. You don't really need a slope and y-intercept on this one. Just take dimes and add the quarters. Of course, the context may change, right? They may not use dimes and quarters, but the idea will still remain the same. Starting at noon, you observe the amount of snow on your lawn during a blizzard. You wrote an equation. You'd have to be pretty nerdy to do this, but you wrote an equation to represent S. How many inches of snow were on the lawn? S equals 0.021x plus 6.5, where x represents the number of minutes past noon. What is the meaning of the S value when x is 1? Okay, so they did give us a slope here at 0.021, and they also gave us a y-intercept. Now, in these word problems like this, the slope is some kind of unit rate, and then the y-intercept is some kind of starting value. So the slope, you know what, I'll start with the y-intercept on this one, okay? So the y-intercept tells us that, because we're looking at snow that's on the ground, or your lawn, so it looks like you're gonna start measuring this with 6.5 inches of snow on the ground, okay? So that's what's already on your lawn. And then the blizzard is adding .021. That has to be inches. This one usually would say this is every hour, but up here it says that this was for every minute, okay? So here, when it says, what is the meaning of the S value when x is 1? So x is 1, that would have to be x, which represents the number of minutes past noon. So that would be 1 minute past noon, because that's when you started to measure the snow. So you take your 6.5 inches that you start with at noon, and then add 0.021 to that, and that would tell you that corresponding y value, which is 6.521 inches of snow. Okay, so two parts to that. Again, it's an ordered pair. You got x is 1, and then the y is 6.521 as an ordered pair if you like it. But again, the 1 just tells us it's 1 minute past noon. We found that value, 6.521 inches of snow. So on this one, since it's asking about x equals 1 on there, the assignment will want something like this. So here we got more interpretation, which again is still part of the objective. At the beginning of spring, you planted a small sunflower in your backyard. The sunflower's height in inches h after w weeks is given by this equation. So what could the number 20 represent in this equation? Good question. They did give us a slope here, which is going to be a unit rate, and they gave us a y-intercept, so very generous of them. But what could the number 20 represent in this equation? Now, it is the y-intercept, but we need to be more specific about that. We're looking at the height of some kind of sunflower here after w weeks. So since we're looking at height, h is the height. Again, think about this. If the w was 0, that would be our y-intercept. So that would be the plant, or I guess the sunflower. I'm going to write plant because it's a shorter word. The plant is 20, let's look at it, was inches. 20 inches, I guess, when you planted it. And yeah, if you want to be more specific, planted it in your backyard, but I'm good with this. There's a roughly linear relationship between the number of times a species of cricket will chirp in 1 minute and the temperature outside. For a certain type of cricket, this relationship can be expressed using the formula T equals 33 plus 0.25 C, where T represents the temperature in degrees Fahrenheit, and C represents the number of times the cricket chirps in 1 minute. So they did give us a unit rate there. What could the number 0.25 represent in the equation? Well, we know the 0.25 right there is the coefficient of C, so it is the slope on that. And yes, again, they gave us the y-intercept. We just don't really necessarily need it here, because we don't need the y-intercept because they're just asking about that coefficient, 0.25. So we know that's a slope, but again, that's not enough to just say it's a slope. we got to tell what it represents. Okay, so what were the two things that were being compared? It said it was temperature and then the number of chirps. So somehow they're recording this, and this would be 0.25. Again, it's a rate, so it should be something for each or per something else. Doesn't really matter how you word that, but looks like 0.25. Yeah, looks like it'll be degrees. So the temperature here is the way they have this set up. It looks like the temperature is dependent on the number of chirps. So that would be, the temperature there is degrees Fahrenheit, and then that would be for every chirp. Seems backwards to me, but well, just be aware that really this doesn't make sense in the, if you were to do some dimensional analysis here, but that's what they're looking for on the assignment. So if you see a problem like this one, now you know what they're looking for, which again, it doesn't really make a lot of sense given the values that were given and the labels, but that's what they want, and you may see it. So there's our objective. I can write equations from word problems. I can interpret x and y values and slope and y-intercept from word problems. Again, we're looking mostly at equations in slope-intercept form, and then I can interpret x and y values in slope and y-intercept from word problems.